Hello viewers, in today's session we are going to discuss an important conceptual problem from differentiability of functions, and in this session we are going to check the differentiability of greatest integer function, that is f of x is equal to greatest integer of x at x is equal to minus 2, right? So here we'll see with the help of the concept of right hand derivative and left hand derivative to check the differentiability of greatest integer function at this integer point, that is x is equal to minus 2, right? So let us start, and here we'll first find out the right hand derivative of greatest integer of x at this point, and then we'll find out the left hand derivative of greatest integer of x at x is equal to minus 2, right? And then we'll draw the conclusion whether the greatest integer function, that is f of x is equal to greatest integer of x, is differentiable or not, right? So let us start. So now let us first define the right hand derivative of a function, say y is equal to f of x. So the right hand derivative is defined by this limit, that is right hand derivative is equal to limit h tends to 0, and we have f of a plus h minus f of a divided by h. And here we have the right hand derivative at this point, that is x is equal to a, and we can here use the notation for the right hand derivative, that is here we write positive, and then here we have the prime, and here we have a, right? And similarly we can define the left hand derivative, that is f, here we have f prime a, and here we put a negative sign, and the left hand derivative is defined by this limit, that is limit h tends to 0, and we have f of a minus h minus f of a divided by minus h, right? So first we'll find out the right hand derivative at this point. So here our point a is minus 2. So we have f prime of minus 2, and we can now write limit h tends to 0, and f of minus 2 plus h minus f of minus 2, and here we have h, and here h is infinitesimally very small, lying between 0 and 1, right? So now here we'll find out the value of f of minus 2 plus h by replacing x by minus 2 plus h. So we have greatest integer of minus 2 plus h, and here we have greatest integer of minus 2, taking x is equal to minus 2, and here we have h. So now we can write limit h tends to 0, and here minus 2 plus h can be written as h minus 2, and the greatest integer of minus 2 is simply minus 2, because we know that the greatest integer of an integer is the integer itself, where n is some integer, right? Okay, so now we have to assign value to greatest integer of h minus 2, right? Now see, h, it lies between 0 and 1, right? So let us subtract 2 throughout this inequality. So we have 0 minus 2, here we have h minus 2, and here we have 1 minus 2. So this is minus 2 and h minus 2, and here we have minus 1. Now from this inequality we can conclude that h minus 2, it lies between minus 2 and minus 1, right? So here we have the real number line minus 1, and here we have minus 2. So this quantity, that is h minus 2, it lies between minus 2 and minus 1. So the greatest integer of h minus 2 is equal to a minus 2, right? So here we can substitute the value of greatest integer of minus h minus 2 as minus 2. So we have limit h tends to 0, and here we have minus 2, minus and minus, it becomes positive, and here we have h. So now this is limit h tends to 0, minus 2 plus 2 is 0, and here we have h. So this limit is now equal to 0, right? So the right hand derivative of greatest integer of x at x is equal to minus 2 is equal to 0. Now let us find out the left hand derivative. So now the left hand derivative is given by f prime of minus 2, and we have this limit h tends to 0, f of minus 2 minus h, and f of minus 2 divided by minus h. So taking a is equal to minus 2. So now we have to evaluate this limit. So we have limit h tends to 0. F of minus 2 minus h can be obtained from this function by replacing x by minus 2 minus h. So we have greatest integer of minus 2 minus h, and here f of minus 2 is the greatest integer of minus 2, and here we have minus h. So now we have limit h tends to 0, and here we have greatest integer of minus 2 minus h, and this is greatest integer of minus 2 is simply minus 2, and here we have minus h, right? Okay, so now we have to assign value to greatest integer of minus 2 minus h. So again I will make use of this inequality, that is this quantity h, which is infinitesimally very small. It lies between 0 and 1, right? So multiplying throughout by minus 1, we have 0. The direction of the inequality get reversed, and now we have to add minus 2 throughout this inequality. So we have 0 minus 2, then we have minus h minus 2, and then minus 1 minus 2, right? So what we have done here, h lies between 0 and 1, multiplying throughout by minus 1, the direction of the inequality get reversed. So we have 0 greater than minus h greater than minus 1, right? And now subtracting minus 2 throughout in this inequality, or adding minus 2 throughout this inequality, we have this one. So this is minus 2, then we have minus h minus 2, and here we have minus 3. So we can now write this inequality as minus 3 is less than minus 2 minus h, and here we have minus 2. So now this inequality suggests that minus 2 minus h, it lies between minus 3 and minus 2. So here we have the real number line, and minus 2 minus h, it lies between minus 3 and minus 2, between these two quantities. So the greatest integer of minus 2 minus h must be equal to minus 3, right? So we have here we have limit h tends to 0, and for this we have minus 3, and then here we have plus 2 divided by minus h. So now we can write minus 3 plus 2 is minus 1 over minus h, and minus get cancelled. We have limit h tends to 0, 1 over h, and this limit, it tends to infinity, right? So from this discussion we conclude that the left hand derivative of greatest integer of x at x is equal to minus 2, it tends to infinity. So now the right hand derivative of this function at x is equal to minus 2 is 0, but the left hand derivative doesn't exist, right? And we know that a function y is equal to f of x is said to be differentiable at some point x is equal to a in the domain of the function f of x, if the right hand derivative and left hand derivative both exist and they are finite and they are equal to each other, right? So here we can see that this condition is not satisfied by this function, that is greatest integer of x, because here the right hand derivative is it exists and it is finite, but the left hand derivative, it doesn't exist, right? So we can claim that this function f of x, which is greatest integer of x, is not differentiable at x is equal to minus 2, because here the left hand derivative of this function at this point x is equal to minus 2, it doesn't exist, right? So this is how by the concept of right hand derivative and left hand derivative, we can check the differentiability of given functions.